to Taxonomy Online Mathematics. This is the second episode of the treatment of the topic Modular Arithmetic. And under this, we want to take construction of multiplication, addition, and subtraction table. Basically, we see questions on multiplication, addition. Subtraction is more or less not that common. So these are the symbols that we use if you are to construct multiplication. It is multiplication sign times in a circular form, addition plus in a circular form, then subtraction in also circular form. Now one trick is that we need set of numbers to construct the table. Meaning if I want to multiply, I need two numbers, 1 times the other, A times B. So I need a set. Good. If you are looking for the set, your set should not include the number given to you, the mode. I believe you get the point. If I am asked to construct a multiplication table mode 4, meaning 4 is not part of my set. As in, if I have mode 4, I am going to construct this table. This is the row and the column. So I put my multiplication there. Now we know that in the clock, in the first episode, you see in the clock we change the 12 to become what? 0 as the starting point. Do you get it? It is in between the starting and the end. So in this time we are not going to begin with 1 and go and end with 0. So you begin with what? The 0. The 4 is the one that we are taking as 0 as the beginning. But we cannot go and put 0 here. So in chronological order, 0 begin. Then the next set, don't forget we multiply two numbers. So the two numbers must be given. So it is going to be in this form. So this is the table of multiplication mode 4. So now let's go. How do we get it? 0 will multiply this. I will print the answer in mode 4, write it down. Multiply in that order. But you can see under multiplication there's a trick. 0 times any number is always 0. So 0 times 0 will give me 0, 0, 0, 0. So easy. The same way 0 times any number will still be 0. So I end up getting the same thing. Do you also remember there's an identity that is 1? 1 multiply every number, remain the number. So 1 times 1, 2, 3. There is no way 1 will multiply a number, that the number will increase. So all the 1 that will multiply will be less than 4, because 4 is on the table. Then you can also agree that 1, 2, 2, and 1, 3, 3. You can see only 2 small space you have to fill with your answer, right? So easy. So 2 times 2. 2 times 2. The answer is what? 4. 4 in mode 4 is rollover. So it's what? 0. Do you get that? 4 in mode 4 is 0. Alright? 2, 3, 6. 6 mode 4 will be 2. I guess you get that. So that will also give us what? 2. Then 3, 2, 6. 6 in mode 4 will still give us what? 2. Then 3, 3, 9. 9 mode 4. 4 will go there 2 times. Remember 1. Okay. So we get that. So in the multiplication, this is all that you need. You only need the mode. In cases they give you the set, construct a multiplication table in mode 4 on the set, then they give you the set. In this case, 0, 1. You just be given this. Multiplication table mode what? 10. The numbers will just be 0 to 9. They will give it to you. Just arrange them. Then you multiply. Did we get it? Good. So other questions that can be asked on this will be that, let's say we have 5 times n giving us what? 2. Find n from the table. From this table. I think I use 5, which is not part of our set, so let me use the 3. 3 times a number. In this, when we get to this place, this is the answer we get from here, from this. So we are only looking into the table. 3 times a certain number, giving me what? 2. So what will I do? I have to hold down my 3. You put your hand on it, put something on it, then be taking it along and see which number on the row will you operate on 3 to get 2. So I don't get. I see 3 operated on 2 give me 2. So here I can say that from the table 3 times 2 equals to 2. Therefore n equals what? 2. This 2. Do you get that concept? So easy, right? You are only looking for the n. Let me see if I've taken it this way. Let's say I have 1 times n. Give me 3. We are looking for a number that is operated on 1 to give us what? 3. So I pin down my 1, then start multiplying. In this row, where do I get 3? 3. So I will just say from the table, 1 times what? 3. Give me what? 3. Therefore, n equals what? 3. So that is basically what the table is about. You only need to look on the table, take your time, fix the number out, then you are there to go. Then there's not much difference between the addition, as in changing here to be addition. You only add the answer, put it back into the mode, write it down. You cannot write 2-digit number. It is always the remainder. Always the remainder. That is all. Is that clear? Alright, let's take one question. Alright, let's see this question. Draw a multiplication table for arithmetic modulo 12 on the set. This is the set given to you. So we have been given a set, which you don't have to start from 0 up to 11. Alright, so let's do that first. So if I have my multiplication in this 1, 2, 3, 4, 9, 11. So we bring it down to have our 1, 4, 9, 11. So if I have this, now we are going to perform the multiplication. So 1, in the previous example, we see that 1 times any number produces the same number, which will not be bigger. So 1 times 1, 4, 9, 11. 1, 4, 9, 11. So we are left with only this nice space to fill. So 4 times 4. 4, 4, 16. So 16 mod 12. That will be 1 remainder what? 4. So I write what? 4. This will be 16. So if you take away this from this, it will be 4. Or if you divide it by this, 1 remainder 4. Alright. 4 times 9. That is what? 36. And 36, this guy will go here 3 times. Remember what? 0. Did you get it? So 11 times 4, we have 44. 44 in mod 12. So how many times will this go here? We know we have 4 times this is 48. 3 times this is 36. So if you take away 36 from here, basically we are left with what? 8. I guess 4 plus this is 40, so 8. So it means this place is going to be 8. So I am done with the first row. I am moving to 9. Don't forget 9 times 4 is the same as 4 times 9. 4, 9, 0. So 9, 4 will give me what? 0. That is, multiplication is what? Commutative. So you can get that easily. So So we go to 9981. So 81 divided by 12. I know if I use 7, let's use 8. 8 times this is what? 70. I think that will be 96. Let's use 7. 7 times 12. And that is 86 or so. So let's take it from 6. So 6 times this will give us our 72. Then if I take 7, which will be 86, bigger than this. So I will take 72 away from this. So 72 from this, the answer will just be 11, right? Will it be 11? Let's see, 11 plus this will give us 3, 8. So we have 9. Let's say 9. 9 plus that will be 1, so 89. So I have what? 9. I'm sure you're with me? Alright. 11, 9 is what? 99. Already we know that 7 is giving us 86. So let's go to 8. 8 will be 96, I guess. So 96 is closer to this. As in, taking this from this, I'll be left with 3. So I get my 3. So I'm going to 11, 4. The same as 4, 11. So I get 8. 11, 9, 11. The same as 11, 9. So 9, 11 is 3. I get 3. I'm only trying to get it so fast because of multiplication is what? Commutative. Alright. So the last one is going to be 11, 11, 121, I guess. If I use 9 here, I get 108. If I use 10 there, I get what? 120. So the difference is what? 1. So in doing this, you take your time. Make sure you get your multiplication right. You see the way I'm struggling using a mental. You can use calculator. Try to get your multiplication right before you perform the division. Alright. So now let's get to the question. 9 times a certain number give us 0. So you're looking for that number. So I'm going to pin my 9 down and look through which number multiply 9 to give me 0. So I can say that from the table, 9 times 4 equals what? 0. Therefore, n I am looking for is just what? 4. Did I move too fast from there? 9 is being pinned down times 4. Give me 0. The answer is 0. The answer is 0. So what number multiply 9 to give it that 0? And that is 4. So you are there so easily. Then the last one is a number times itself. That is n times n. Give me 1. So when I pin 1, I go to 1. When I pin 4, I go to 4. I'm not going to go through. When I pin 9, I go to 9. So 1, 1, I get 1. So this is my answer. 4, 4, I don't need it. 9, 9, 9. Then 11, 11, 1. So it means that from the table, 1 times 1 is 1. And 11 times 11 is also 1. Therefore, n is equals to 1 and what? 11. Do you get the concept? So multiplication table for modulo is nothing but so easy. If you can remember, the modulo is a remainder theorem. Just the remainder. Just what? The remainder. So I believe with this, you can be able to construct for addition and, if possible, subtraction. So your task or your homework is construct a multiplication table for arithmetic modulo what? 7. Mod 7. use all the set right from 0 to 6 and see if you can be able to do that. I believe as at this point you are nodding your head, smiling. I don't know. I thought the topic modulo is that difficult, but today you grab the concept. If you like the concept, you like this video, then subscribe to the channel Taxonomy Online Mathematics. Like the video, share with people. Take it upon yourself. Say, I've gotten this information so easily. Share with your colleagues. Those who think may need it. Share with them. Let them also subscribe and click on the notification bell so that they will also get access to the next video I'll upload. Comment if possible. Send me questions if you have. Then I'll be glad to answer you. Don't forget, we are into this together. So together we move forward. The name still remain Taxonomy Online Mathematics. See you in the next episode. Until then, bye bye.